Hey everybody, welcome to today's lesson. It's going to be pretty short. We're going to focus on pH, so I do suggest jotting a few of these things, or jotting this stuff down for today. We're eventually going to get into calculations, so eventually we'll need your calculator. Hopefully you have some kind of scientific calculator that can do what is called a logarithm function, or a log function. Maybe you've used them in math class before, I'm not entirely sure, but we'll look at that a little later. But either way, we focused on pH the week that we left, I guess. We just focused all on acids and bases. So I know we talked about pH a little bit and just what different substances were at what different pHs earlier. We did that lab the Monday before we left school, figuring out what things in the house were acids, what things were bases, what things were neutrals. Here's a couple little more things about pH in general. We focused a little bit on, again, what acids were, what bases were, but in general, again, this is just very basic. This is the basic definition of acids, bases. I know you had the vocab from before we left, but I want to focus on these a little more today. So acids are substances with more H plus than OH, and we focused on naming and writing formulas of acids. And one of the general trends you saw was that every acid had some kind of H at the start of the formula. And that H comes from what's called an H plus ion, a hydrogen ion, hydronium ion. But acids have more of these than OH minus ions, while bases have more OH minuses than H pluses. But what's interesting is that all solutions include both of them. Okay? So it's not just that acids only have H pluses, but in a solution, both are actually present, and in a base, like any carbonated compound or any hydroxide compound, ammonia compounds, ammonia solutions, they have OH minus and H pluses. They actually include both. So to give you an idea or an example and a picture, again, for all the videos, you can obviously pause and stop things as I go. But for instance, water is a pH of 7 and is completely neutral, but that doesn't mean it has neutral particles. It just means that the H and the OH are actually in perfect balance. So in my little picture, I've got 10 H plus, or red H plus dots, and 10 OH minus blue dots. And you can see that there's no extra H plus, there's no extra OH minus. They're actually in perfect balance. So that is known as a neutral substance. Now, if I took out like 9 of these blue dots and made them red, then there would be 19 reds and 1 blue, which means that would be an acid. It would have more H plus than OH minus. The OH minus would still be there, but it's just not enough to make it neutral and not enough to make a base. Now, if I again turned 9 of these reds into blues, it would be known as a base. It would have a very high pH because there would be 19 blue ions, blue OH minus ions, and 1 red H plus. So that just gives you an idea, a little picture of what's going on. But more about pH is that it's based on the logarithm scale. What else is based on logarithms is the Richter scale. So if you ever hear about the, certain earthquakes having a Richter scale, a certain number on the scale, it's not just like, twice as intense. Actually, everything's based on 10 times. So if you look at two very popular substances, milk is a pH of 6, water's got a pH of 7. Milk is not just like 1 unit lower in the pH scale, but it's actually 10 times more acidic than water because pH is based on logarithmic scales, and that's based on the number 10, based on the power of 10. So that means there's 10 times more H plus ions in milk than there are in water, at least that ratio. Again, the way we get the 10 times is that 6 and 7 are 1 unit of pH difference, and that is 1 10 value. So if you look at lemons and tomatoes, lemons have a pH of 2 and tomatoes have a pH of 4. That's 2 pH values, so that's 10 times 10, so 100 times. So that's why, again, lemons, again, lemons and tomatoes, the pH doesn't look too crazy. I mean, 2 unit difference isn't a lot, like $1, $2 versus $4, but 100 times is crazy, okay? Imagine if you were 100 times taller. Okay, there you go. 100 times is a lot. Even 10 times. Imagine if the school day were 10 times longer. You'd all go nuts. Okay, so 10 times is a crazy amount. Don't think it's not, because it is. Okay? Or imagine what you want to be in the future, all right? What you want to do as a career. Imagine making 100 times more money. Okay, there you go. 100 times, or 100 times less, or 100 times fewer. Okay, it's a big amount. It's nothing, it's not minuscule at all. And then the other side, you can also talk about bases the same way. So Tums, pH of 10, are 1,000 times more alkaline or more basic than water. Water's got a pH of 7. That's 3 pH units different. And so that's 10 times 10 times 10, which is 1,000 times. So again, that means there's 1,000 times more OH minus ions in Tums than there are in water, or at least that ratio is 1,000 times different. So that just gives you an idea of what pH actually means. It's just talking about the ratio of H plus to OH minus. So low pHs are your acids, again, and high pHs are your bases. Now we're going to get into some of the calculations, so let's get your calculator out. We're going to do some math.